I have some questions that I'll let you go.
Okay, sure, shoot.
And I'm not sure exactly, I'm not asking specifically about a question on the test, but it's an issue that I don't understand. If you look at the beginning, it asks you to recode your data, which is understandable, but it says a period is missing, and I don't see it. I looked all over, up and down, and I don't see the period missing anywhere.
Then there isn't anything missing.
Okay, well, I just wondered. I mean, that's a wild goose chase, and it says there's a space missing too, and I don't see it.
Not a wild goose chase. It just was a reminder for people to check their data.
Okay.
Right? So you should never assume that your data is okay.
Well, I've looked at it, and I just don't see it anywhere. But
okay.
And the other question, I had two other questions. Is number and frequency appropriate and percentage appropriate for all kinds of variables? It appears to be, from what I can tell. I just
it's appropriate for everything but a true numeric continuous value. Right. But even then, sometimes you can say, well, 30% of our people are less than the age of 30. Right. Even if you're reporting means and standard deviations on age, you can still,
Okay. And then I'm having a hard time understanding what the population of inference is.
Okay.
I know sort of intuitively, I can't separate between the sample and the population apparently. Oh, here's some more people.
Candace is joining us.
That's good. Somebody else got some questions maybe. But I'm having a hard time understanding how you get from sample to population. I understand intuitively, I just don't see it. I can't somehow bridge that gap in my mind.
Okay. So the question, Candace, you just joined us, is what's the difference between a population and the sample? So
I know the difference. I just don't understand how you get from one to the other.
Right. So the population, let's think about it this way. The population is comprised of everyone that has that disease or condition. Right. Or that exposure, or, it could even just be literally the general population, right? But if you think about something like if we're doing a weight loss study and you have enrolled people to change their diet, increase their exercise, or both change their diet and increase their exercise. Okay. You would have a list of inclusion criteria for the people who could be in your study. You obviously wouldn't enroll people who were of normal weight. You probably wouldn't enroll people that had concomitant diseases or who also were type 1 diabetic, because that gets into other issues. So you'd have this listing that defines your population that you're looking for. And it would be people with a BMI of a certain amount, pre-diabetic, not currently taking insulin. That's going to define the population of people. Okay. And then you're going to sample from that population.
I got you.
Because there's no possible way that you could get everybody in that population to participate in your study and do what you need them to do, right? So you're going to take a sample from that population. It should be a well-designed study. The sample should be of sufficient size. Then when you get your sample collected, we utilize our statistical techniques to describe our sample and to answer our statistical question. That then allows us to make inference back to the larger population.
Okay.
So if your study is well conducted, and that's why, let me share my screen here. I'll show you. I just sent an abstract off to someone where we've been working on this for a while. And that's why you'll see things. There's going to be a lot of red when this pops up. And don't screen grab it because we haven't submitted it yet.
Hey.
This is not your abstract to steal.
I promise I won't do it.
Okay. But I wanted to show you something here very specifically, is that the very first part of our abstract here tells us how many people were randomized, tells us how many are included in this analysis, right? That's actually on our midterm, right? How many people were included. in the analysis, and why. And then it describes that they were a median age of 38 with a range of 18 to 61, 72% female, 88% white, 1.2 years since disease diagnosis, and 2 relapses in the prior 12 months. So this tells people when they read this paragraph who these results apply to. What's our population? It's already stated up here that this is relapsing remitting MS, but we know that it's relatively new diagnoses. They have somewhat active disease. Here's their median disease scale score. It's largely female and largely white. So you wouldn't want to say apply these results to Asian males necessarily. Like that's not this population. This population is a pretty straightforward relapsing remitting white Northern European young disease status. So all of our results here we can make inference back to that population. And
that's the whole purpose of what we're doing, right?
Yeah.
Well, see, I somehow I always like to be able to understand the essence of what we're doing, and it makes sense now because I just didn't see that before.
Yep.
I mean, I sort of knew it, but now I understand, and I appreciate that. That helps me a whole lot. So
yeah, absolutely.
It's one of those things. The population has to look like the sample, or else it's of no value, no meaning at all.
Correct.
I got it.
Yeah. So it's not necessarily, and this is where I would say 9 times out of 10 the media gets it wrong.
Right.
Because you'll hear big splashes about something, but if you go, and now you know what to look for. If you go pull up the actual study. Thank goodness for hyperlinks these days, right? If you read
right.
the news brief, they'll say in a study, and it's usually linked, and you go look at it, and you can make the determination as to who is this applicable to, because the media will generally just announce like it's the regular population, right? That this impacts every single person, but it doesn't usually do that. And there's better inference in some disease populations than in others. So if you think about something like MS or myasthenia gravis, cystic fibrosis, those are what are called orphan or rare diseases.
Right.
And they tend to be pretty homogeneous disease populations. So those studies have a little bit more population impact than, say, something that's done for obesity, because obesity is, pervasive. And so you really have to look at who is in the study on obesity to determine whether or not it's applicable to you or your patients or your clinic or whatnot.
That's very helpful.
So I have a question about correlation. So
Sure.
So this is the question I have. So when we state like the interpretation of the data, like saying whether it's a strong or a positive correlation, do we still mention, like, I'm confused on when do we have evidence and don't? Like, say we have evidence of a strong positive correlation between, like in the example was like smoking prevalence and cancer was the example on the notes for correlation.
Yep.
So if we were, in this case, what we did was we rejected the null hypothesis.
Right.
So if we fail to reject the null hypothesis when interpreting the data, we still put it would be like a weak negative, in other words, right?
Right. So let's go back here. Right. So this is our, you could think of it as, right. These are our two not plus. These are our two options for, here comes our Shipt shopper. I introduced my mother to Shipt, and she is like in heaven that she doesn't have to go to the grocery store. Well, we're on a pretty small island, and the cases have tripled in the last week here.
It's crazy here too.
Yeah, they're almost at 1,000 cases for this little tiny island. So anyway, back to this. So no correlation, right? And so we're gonna the first thing that you do here after, so you run your fit y by x, right? And you get a p-value. And there are really two options, right? P-value greater than alpha. That means we're going to stick with H naught, right? Therefore, It doesn't matter what R is.
Okay.
Because it's not different from 0. So that's one of those situations where you can say, while we observed a correlation of 0.47 or whatever it was not statistically significantly different from 0.
Okay.
And so there's just really, it doesn't matter what it is because it's not different from 0. Our other option here, right, is that our P value is small, usually less than 0.05. That's going to take us to HA. And in this case, you want to report the direction, right? And that's positive or negative. You want to report the strength, right? And that's going to be, there's any number of ways you can say it, but mild, moderate, strong is a good indication, or weak, moderate, strong is also just sort of whatever word feels comfortable to you. There's no general or required, and then you actually want to, give those values, but then you also get to interpret it, right? Interpret the strength. If I can type NGTA. So, if it can be statistically significant, but the correlation could be 0.05, it could be 0.07. So it could be very mild. It could be a very weak correlation. So while the correlation's not 0, it is not a strong relationship. And that's up to you. And it goes right back to, what are you asking? If we're looking at age predicting cholesterol, any amount of correlation is kind of helpful, right?
Okay.
But if you're looking at a new test replacing an old test, right? So a new fast, rapid blood draw versus something that has to go to the lab and be spun down and takes, weeks to get back and is very costly. You want that correlation to be really high, because I'm not going to replace a gold standard test with a new test if the correlation is only 0.10.
Okay.
You see what I'm saying?
Does
that make sense?
Yep.
So that's really the thing here is that, again, what I'd said this before for people is that, I don't know why this is doing that, but I had said this before, that the p-value is a tool, right? And the p-value, all the p-value does is help us pick between these two things. It doesn't actually, the p-value doesn't do these things.
Okay.
You have to do those things. Like JUMP will give you the direction and the strength, but you have to make the interpretation as to what that means. And after the midterm, when we get into fitting a line, like fitting linear models, we'll talk more about going from correlation to a linear fit, where you actually get those values that say for every 5-unit increase in age, cholesterol increases this much. And so you'll get better at the interpretation with a little bit more information.
Okay. I think that was the only question I had. Let me make sure.
I'm actually about to do next week a whole bunch of correlations for people on jaw measures.
Well, at least you understand it, though.
That is true. I do have a solid.
Unlike me.
I do have a solid understanding of correlation.
Yep. So I think that's all I have.
Great, fantastic. Well, if you have any other questions for the next couple of hours, just make sure to shoot them through Canvas email or on the midterm discussion board, and I'll answer anything that's posted by 5 later today.
Okay.
But I feel like you guys are both in good shape.
Thank you very much.
Okay.
Absolutely.
Thanks so much.
All right, have a good long weekend.
Bye-bye.
You too. Bye-bye. Bye-bye.